Hello, and welcome to this screencast about testing Python with pytest. In this three-part video series, I'm going to be talking about the motivation behind why we test software. I'm going to demonstrate some functionality of pytest, which is a testing framework for testing Python, and a couple of words on best practices that I've picked up. This screencast is a kind of repeat of the presentation I delivered at the Southampton Python User Group in November 2017. But before we talk about Python and testing in pytest, I thought I'd introduce myself a little bit. So this is me in the top left. I've been using Python Python since 2008, and I've been involved in various projects. One of these projects was for my PhD research at the University of Southampton, where I investigated very small-scale magnetism. I used Python to create a simulation package, which, along with many of my colleagues in the office, and we also created the means to visualize data, all using Python and all very well tested using pytest. So, why write tests? This is motivating the purpose for testing. I mean, obviously, the primary objective is to show that your software is fit for purpose. That's what testing is for. But there's, if your software is working and you make some changes to it, you want to be able to tell whether or not the changes you have made whether or not they break your software or whether your software continues to function the way you want. Tests allow you to do this because by running the tests before you make your change and by running the tests afterwards, you then have clear proof that the code functions in the way that you would expect in both cases. Now, this is a very powerful tool because if you can make changes and ensure that they don't break your software, that gives you the confidence to make bigger changes, more changes, and refactoring and things like this, which you would otherwise have difficulty to do without testing. But the confidence doesn't just rub off on you, it also rubs off on other developers who are working in the team as well, because they then can tell whether their changes break some other part of the software that they're not involved with directly. So it's not just you and developers that this benefits, it also benefits your end users. In academia, simulation software is typically not easy to install, and when you do install it, you want to make sure that your software works as you want it to before you start configuring it and running simulations and things like this. So tests can give the users confidence as well that your software works as you intend. So these are some very striking reasons as to why we should write tests, but there are some reasons why we shouldn't. Now, the first reason that I tend to encounter the most when I talk to people about this is, but I know the code works. I mean, it's so simple. I mean, I've understood it, I've designed it, of course it works. Now, this logic, it holds for some software, for simple pieces of software where you really understand the internals and it's very clear to every developer that would ever look at it that it is very simple, then you probably don't need tests. But for most other pieces of software, particularly complicated pieces of software, it's very useful to have a testing suite because you may know how it works, but others certainly won't, and you may think you know more about how it works than it really does. And that's a common trap that people fall into. Another reason not to write tests is testing takes time. We are writing code to test our software after all, and in addition to time, it takes skill because it requires a different mindset. So where the software developer is more of a problem solver, a test engineer might be more of a problem definer type of person. And that's quite a paradigm shift for people, and that can be difficult. And it's quite important to get the tests right. It's quite important to have these skills and to allocate the time, because if you do your test badly, somebody makes a change and the tests still pass, but they've actually broken the software, then you're giving people false confidence. People think that their changes have worked, but apparently they haven't, and now your software is broken and you can't really easily diagnose where the problem is. So bad tests really can give false confidence to, again, yourself, your collaborators, and your users as well. And the last point I've got here is an increased code base, because of course tests are code, and more code means more maintenance. Now, at the risk of sounding patronizing, I want to emphasize the point that if you do write tests, make sure you do them well. If you do a bad job, or a halfway house job, you can mislead people, and tests done badly are worse than no tests at all, basically, is the long and short of it. So, before we get on to actual PyTest, I thought I'd talk about what we want our tests to do in detail. Not really why we're doing them, but more what we want from them. So again, the obvious shows the software is working comes up. That's, kind of what people think of when they think of tests. What we'd also like, though, is the ability to understand why the software has broken from a change. Failure diagnosis is a critical piece of functionality that you would find from a test suite or testing framework. It's also convenient to reduce the amount of the amount of tests in terms of code you're writing, so it must be convenient to test the software under many conditions. And I'm calling this parameterization because that's kind of how the engineers look at these problems, is a set of similar problems that can be described by just changing a parameter or 2 or 3 or 10. There is the fact that as your code grows, your simulation or your industrial project or whatever it is, as your code grows, you have more things to test. And when you have more things to test, your tests take longer. So there's only a finite amount of time in the day, so we need ways of making our tests run more efficiently or just plain faster. So a good framework for testing must have a way of making tests run fast. In addition to this, software is typically quite tightly coupled. You can modularize your software by breaking it off into, modules, but oftentimes you need to specifically test pieces of software in isolation. I'm going to talk more about this topic in part 3 of the series here of the videos, but this can basically be achieved by mocking. But it is an important feature because it means that you can determine, again, what has exactly failed more easily. And there are many more kind of features that you might be interested in depending on your application, but these 4 at the top I'm going to focus on in this series of videos. So that kind of concludes the first video I have to talk about. Next time we're going to come back and talk about some PyTest scenarios with some code examples, and we'll see how many of those we can get through. Thank you very much for watching my video. Please check out the next part if you're at all interested, and I will see you in the next video. Thank you for watching.